Thanks, Paul. And is this mic okay? Apologies. I'm a hand talker, so I might knock it around. I should also mention that I published under my maiden name Bauman until 2013, and then my married name Wormwood thereafter. So you'll see cites from both throughout. So this is a still shot from a video taken aboard an Apache helicopter in Baghdad, Iraq in July of 2007. In the video, the soldiers aboard the helicopter identify one of the men shown here as holding an RPG, which is a rocket-propelled grenade. And I know the resolution's not great, but it's the gentleman in the darker slacks near the center of the crosshairs, and you can see the weapon over his right shoulder. So in the video, the soldiers, they call this in, they wait for all of the appropriate permissions to engage the combatants, and then they open fire, killing the men. We're looking at this still shot today because it was discovered after the fact that these men were not, in fact, combatants, as the soldiers had thought, but were one of Reuters' top freelance photographers and his driver. So the RPG turned out to be a camera with a telephoto lens. Now, as someone who's interested in emotion, one of the most striking things about the video is the emotional atmosphere aboard the helicopter, and the use of really strongly emotional language by the soldiers throughout the video. And so here's some snippets of that dialogue. I do apologize, it's a little on the R-rated side. The dialogue's unique because it offers us a glimpse into the emotional experiences of these men in the very moments when they're making decisions about the men on the ground as potential threats to their safety. I'd also like to offer some examples that maybe hit a little bit closer to home. So even post hoc accounts of similar perceptual errors seem to highlight the same experience of heightened negative emotional experiences in the moments when people are making decisions about potential threats. So, as I said, I'm going to share some other examples. These are quotes from police officers here in America who've shot and killed unarmed youths within the last 4 months. So I was scared to death. The last thought I had go through my mind when I pulled the trigger, and I'll never forget this, was that I was too late. And he had the most intense, aggressive face. The only way I can describe it, he looks like a demon. That's how angry he looks. Now, if you're familiar with any of these examples, you should know, or you probably know, that the victim's race likely contributed causally to the errors in threat detection that occurred. And there's been a lot of research, a relatively substantial body of research now, to demonstrate just that, that race and racial stereotypes influence how we perceive and respond to potentially threatening individuals. What I want to convince you of today is that there are other causal factors here that are being overlooked, namely someone's emotional state. And I think these examples highlight that nicely. And so what I'll show is that even when we hold target race constant, we'll demonstrate changes in threat detection being driven by how someone's feeling in the moment. So to start, I want to provide just a little bit of background about what emotions are and how they're thought to function, just to kind of lay the theoretical groundwork for the research that follows. So I come from a background in constructionist theories of emotion, which posit that emotions are complex mental phenomena comprised of more basic psychological components. That is, an emotional experience is created, it's constructed, when we use conceptual knowledge from language, our past experience, from our culture, to make meaning of physical sensations from the body and the world around us. This is far from a universally agreed upon definition of emotion. There's actually a very active debate right now about what emotions are and where they come from. That is beyond the scope of this talk. We would be here all night. What is relevant for this talk is a point of agreement. So, regardless of their theoretical background, emotion researchers seem to agree on one thing, and that is emotions are functional. Emotions help us contend with emerging threats and opportunities in our immediate environment. And emotions are thought to be functionally unique. That is, each distinct emotion helps us contend with a specific or specialized set of circumstances. For instance, feeling a negative emotion like anger may help you prepare to cope with threats of potential violence or aggression, while feeling another negative emotion, say disgust, will ready you to contend with a very different set of threats, threats of contamination and disease, for instance. So despite my opening example where I suggest that emotions may have causally contributed to some very serious errors in judgment, I do want to stress this point that emotions should be thought of first and foremost as functional, particularly in the service of survival. That said, emotions can be misattributed to an unrelated source. So an emotional state can be carried over from the original situation that elicited it and then used to guide decision-making and behavior in some new unrelated situation. And it's these circumstances where we most readily or most easily observe how emotion can bias decision-making and behavior. Though it should be clear here that the term bias, as I'm using it, is not meant to imply maladaptive. Right? So a bias in the service of some underlying function could be adaptive or maladaptive, depending on the circumstance in which it's brought to bear. Okay, so that negative emotions should influence the way we perceive and respond to threats is implicated in really most emotion theories concerning the most basic function of emotions. That said, there's very little direct empirical support for this claim, particularly when you talk about objective decisions, so decisions where there's a clear correct and incorrect response. Moreover, people who study threat detection really stress this idea that it occurs automatically. It's outside of conscious awareness or control. Nevertheless, some research outside of emotion has demonstrated that situational factors can influence threat detection performance, despite the speed and automaticity with which it's thought to occur. So for example, I mentioned there's been some research on race and racial stereotypes. Josh Carell and his colleagues at the University of Colorado in particular have done some work with a simple video game where they ask participants to shoot armed targets as they show up and not shoot unarmed targets. And what they find is that participants consistently make more mistakes shooting unarmed African Americans than unarmed Caucasians. And it's the activation of the stereotype associating African Americans with violence that drives this bias in responding. And though I won't be talking about race today, I will be using a modified version of the same task throughout the research I'll discuss. And what I hope to show is that other situational factors, like someone's emotional state, can also affect threat detection, again, despite the speed and automaticity with which it's thought to occur. So I'll focus for the bulk of my talk today on the detection of guns, a stimulus associated with threats of violence and aggression. And so I'll also focus on emotional experiences that have some conceptual overlap with that particular threat. So for instance, I'll first talk about a set of 5 studies examining the influence of anger, an emotion related with threats of violence and aggression. I know some of you are maybe more familiar with this particular work than others. So if you're familiar with it, hang in there. I'm also going to talk about some new data. So I'll also look at emotional experiences following a real-world instance of threat, the Boston Marathon bombings of 2013. And I'm really excited because I'm going to share some data from a project we just finished data collection on less than a month ago. And finally, I want to spend the last few minutes of my talk situating these specific studies in terms of my broader interests on affect and emotion and decision-making more generally. Okay. We'll get started. So as I mentioned before, the experiments I'll describe today all involve a modified version of Josh Carell's shooter bias task. It's modified because participants are asked to merely identify whether or not a gun is shown, as opposed to making shooting decisions, and they also are shown only Caucasian male targets. So this task plays like a simple video game on the computer. Participants are asked to press one of 2 keys on their keyboard to indicate whether each individual who appears is holding a gun or a neutral object. And this can include wallets, cameras, cell phones, or soda cans. And they're asked to make these responses under time pressure. So they're asked to respond in less than a second while the individual is still being shown on the screen. And I have 2 sample trials, just for anyone who's unfamiliar with the task. Give you a sense of what this looks like to participants. Everyone ready? They go a little fast. Okay, so I know that goes a little fast, but hopefully it gives you an idea of how the task actually unfolds, what it actually looks like to participants, and gives you a sense of like the timing. We analyze performance in the threat detection task using signal detection theory. And in a signal detection analysis, you talk about correct and incorrect responses separately for the gun trials and the neutral object trials. So the gun trials in our task are what might be called signal trials in a signal detection analysis. So correctly identifying a gun when it's shown is called a hit, and misidentifying a gun as a harmless everyday object is called a miss. Our neutral object trials are what might be called neutral, or noise trials rather, in a signal detection analysis. So correctly identifying a neutral object as such is called a correct rejection, while misidentifying a neutral object as a weapon is called a false alarm. And so what signal detection theory does is it uses the proportion of trials that fall into each of these 4 possible outcome categories in order to break a participant's performance up into separate measures of their response bias and their sensitivity. And this is really the benefit of using a signal detection analysis. Now, instead of just talking about how anger influences overall performance on the task, we're able to talk about whether anger influences how readily people are able to distinguish guns from non-guns, or whether it affects their willingness to make certain types of errors over others. And so as I said, we calculate two parameters for each participant. Sensitivity, or D prime, is an index of how sensitive the participant is to the distinction between guns and neutral objects. And in this task, you can think of it as akin to overall accuracy. The more sensitive someone is to the distinction, the better able they're going to be to tell them apart, and so the less errors they should make overall. The other parameter we calculate is a measure of response bias, sometimes called criterion or criterion center. I'll indicate it with a C. And this is a measure of how much information a participant needs before they're willing to say a gun is present. And you calculate it by looking at the relative proportion of those two different types of errors. And so for our task, a bias value of 0 indicates a lack of response bias. It indicates that the person's not favoring one response over the other. Negative values indicate what we'll call a liberal response bias. And so in our task, this indicates the participant is favoring the gun response. And they're going to make more false alarms than misses. So you can think of a liberal bias as kind of the shoot first, ask questions later bias. You're favoring catching every gun at the expense of maybe making some mistakes, catching some extra things that weren't guns. On the other hand, a conservative bias will be indicated by positive values of this measure. And for our task, this indicates favoring the non-gun response. Right? So you're going to make more misses than false alarms. All right, so for the first set of studies, before participants complete that threat detection task, they all complete an emotion induction procedure. And for this first set of studies, it's always an autobiographical recall task. And we used this because it's been used in a number of past studies examining the influence of emotion on decision-making and behavior, and it's been shown to reliably elicit discrete emotional experiences. Here's a little snippet of someone's recall data. In the task, you basically ask participants to think back about a time in their life when they remember experiencing a specific emotion. They're asked to relive the experience, to recall it as vividly as possible, and then to write about it in as much detail as possible. And in our experiments here, our neutral participants or our control participants wrote about just their typical day. Okay, so the first two studies are nearly identical with the exception of which emotion inductions were induced. In study 1, participants completed either a neutral, an anger, or happiness manipulation. And in study 2, they completed either a neutral, an anger, a disgust, or a sadness manipulation. And the prediction here is that the anger manipulation and the anger manipulation only will influence participants' threat detection in this task, with the idea being that the emotional state needs to be relevant to the decision at hand. So while anger could typically be elicited in situations involving the potential for violence or aggression, such as those involving guns, that's not true of the other emotions here. And so we don't expect participants to utilize them as a source of information when they're trying to decide if someone's armed. Moreover, we chose these specific emotion conditions as comparisons in order to rule out alternative explanations based on valence or arousal. So what you see here is Jim Russell's affective circumplex. And what it does is it just maps out the different discrete emotions in terms of their felt valence, so pleasantness and unpleasantness, and their felt arousal, so how activated and deactivated they feel. And so in study 1, we wanted to compare anger to an emotion of equally high arousal but opposite valence, which is why we chose happiness. And in study 2, we wanted to demonstrate that this effect would not occur for just any negative emotion. So we chose to compare it to a negative emotion of equally high arousal, which was disgust, as well as a negative emotion of low arousal, which is why we chose sadness. Moving on to results. What you see here are the mean sensitivity values for each of the different conditions in both of the studies. And what you'll notice looking down this column is that sensitivity does not differ by emotion condition. So it's not the case that our anger participants are more or less sensitive to the distinction between guns and neutral objects. And remember, you can think of sensitivity as akin to overall accuracy. So it's not the case that our angry participants are making more or less errors overall on the task relative to people in these other emotion conditions. When you look at bias, however, and again here these are mean bias values for each of the different conditions, you see that it's in both studies the anger condition and the anger condition only where participants have this significantly negative bias value. And again, that indicates a liberal response bias, whereby they're favoring the gun response. To help you visualize what this means, I want to look now just at the results from study 2 in terms of error rates by trial type. Right, so here are the results from study 2. You'll see percentage of errors on the y-axis, and the different trial types, object trials. Errors on object trials are represented by purple bars, and errors on gun trials by blue bars. So what you should see when you look at this figure is that angry participants are not making more or less errors overall. If you added the two bars together, it's relatively the same for each of the different conditions. What is unique about anger or angry participants is that they're making a different proportion of the two possible types of errors, right? So they're favoring making false alarms so that they can avoid making any misses. And so this is what a liberal response bias looks like in our task. And what I'm going to do for the next 3 studies is examine the causal mediators of this effect. So what is mediating anger's influence on bias? So based on past research, we thought one of the most likely potential mediators would be participants' expectancies for encountering threats, for encountering guns in this task. That is, there's been some past research to suggest that experiencing an emotion biases probability estimates for emotionally congruent future events. So feeling sad makes you think you are more likely to encounter an event that will make you sad in the future. And this effect has been shown to be emotion specific. So anger, for instance, makes you think you're more likely to encounter an event that will make you angry, like getting stuck in a traffic jam, but not necessarily more likely to encounter an event that would make you sad, like losing a loved one to disease. Well, you'd make the opposite predictions for experiencing sadness. And so it seems possible that our anger participants expect to encounter more threats, more guns in our task, and so this may be a viable mediator. The other evidence that this may be a viable mediator comes from signal detection theory, which explicitly lays out some parameters that should influence a person's response bias. And one of those is the relative proportion of neutral object and gun trials. So for example, all else being equal, if a participant enters the task thinking that there's going to be the same number of guns and neutral objects, there's no reason for them to favor one response over the other. That is, on a trial, when they're uncertain, they're just as likely to be correct by chance alone, regardless of which option they choose. And so generally, all else being equal base rates indicate no response bias or no need for response bias. On the other hand, if you expect the task to contain more guns than neutral objects, then the optimal decision strategy is to favor the gun response. Right? So on a trial, when you're not sure what you actually saw, you're actually more likely to be correct by chance alone if you choose the gun response. And so all else being equal, if you expect there to be more guns, you should adopt a liberal bias. You should favor the gun response. And so what this suggests is, if our angry participants expect to encounter more guns, it should produce exactly the type of bias we saw among our angry participants in the previous 2 experiments. So again, we feel like this is a good potential mediator. So before we could test mediation, we first needed to establish whether our angry participants actually expect there to be more guns in our task. And so this is what we did in study 3. Participants completed either an anger or a neutral manipulation, and then they completed a modified version of the threat task where they made decisions in the absence of any actual stimulus information. So essentially we told participants, you're going to be shown people holding guns and wallets, but the guns and wallets are going to be flashed so briefly on the screen before being covered up that you won't be able to consciously see them. But we want you to try to identify what was shown regardless. And so on each trial of the task, participants now see something like this, where the gun or neutral object is covered by a blurred black and white circle. And they see this for just 50 milliseconds. And it's just to give them the visual impression that we have indeed shown them something very quickly before we covered it up. So then it's covered with a gray circle like this. And participants are asked again, when they see the gray circle, is this man holding a gun or a wallet? And here are our results. Consistent with our predictions, you'll see our angry participants indicated by the red bar. We predict more of the trials contain guns than our participants in the neutral condition, represented here with the blue bars. And while this is promising, we also wanted to rule out the possibility that this is just another measure of response bias, right? Angry participants, everyone's making a response on every trial, so maybe our angry participants just like pressing the gun button more. And so to control for this, we ran another experiment, experiment 4, which was nearly identical. It had the same cover story, the same stimuli, but the threat detection task just played through like a movie. And we had told participants, we just want you at the end of the experiment to tell us how many trials contain guns, how many contain neutral objects. And here are our results for that. Very consistent with experiment 3, we see that our angry participants predict more of the trials will contain guns than do our neutral participants. And so studies 3 and 4 together demonstrate that experiencing an emotion can bias probability estimates for encountering emotionally congruent events. Our angry participants do think that they're going to encounter more guns than our neutral participants. Moreover, this is important because even though past research has demonstrated experiencing an emotion can bias probability estimates for emotionally congruent events. Those studies have all looked at estimates for hypothetical future events. And so this is really the first indication that an emotional state can influence these estimates, these expectancies, for events that are actually taking place right in the moment. So events that are more temporally and experientially immediate. Okay, so now that we've demonstrated anger can influence base rate estimates in our task, in the moment, we're now ready to finally test whether or not these biased base rate estimates are our causal mediator more directly. And so to do this, we use a methodology recommended by McKinnon, whereby you experimentally manipulate the proposed mediator. Essentially what we did was we manipulated base rates explicitly in order to prevent participants from using their own subjective base rate estimates. And we wanted to really accomplish two things. Sorry. First, we wanted to see if we could produce the bias among neutral participants where it had never occurred before by telling them to expect more guns in the task. That is, we wanted to see if we could produce the effect enhancing the mediator where it would normally not be enhanced. The other thing we wanted to do was see if we could block the bias from occurring among angry participants by telling them to expect a relatively equivalent number of guns and neutral objects. In other words, we wanted to block the effect by constraining the mediator where it would normally not be constrained. And so this is what we did in study 5. It's a 2-by-2 between subjects design. Participants completed either an anger or a neutral manipulation, and then they completed one of 2 versions of the threat detection task. And here we're back to the original setup, so no more covered up images. And participants either completed a version where they were told half the trials contain guns and half contain neutral objects, or they completed a version where they were told more of the trials contain guns than neutral objects. And the base rates in the actual tasks were manipulated to be consistent with these instructions. And so here are our results. You'll see the average bias for each of the different conditions. And again, our angry participants are in red and our neutral in blue. And the first thing you probably notice is this very large base rate main effect. And that's to be expected, right? According to signal detection theory, as long as our participants are motivated to perform well, they should be adjusting their response bias for different base rates. And so, as you'd expect, if you tell people to expect to encounter a lot of guns in the high gun conditions on the left, they set a negative bias, a liberal bias, where they're favoring the gun response. And if you tell participants to expect a relatively equivalent number of guns and neutral objects, such as in the even split conditions on the right, they don't favor one response over the other. They set a neutral response bias. What's more important to our mediational test, however, is the emotion main effect. Right? So if anger is not influencing bias through its impact on base rates, then our manipulation of base rates should not detract from the effect we'd seen in previous studies. However, there is no emotion main effect. If the emotion main effect had remained, what we should have seen was anger participants had a more liberal bias in both conditions, in both base rate conditions. So the red bar should have been lower than the blue bar in the even split conditions. And again, same pattern, red bar lower than the blue bar in the high gun conditions on the left. So not only do we not find an emotion main effect, but the means aren't even in the predicted direction anymore, suggesting that this null effect is not the result of low experimental power or the emotion effect size being small relative to that base rate effect size. So ultimately, we were able to block anger's ability to produce a liberal response bias by manipulating base rates explicitly, by making it so participants could not utilize their own subjective base rate estimates, suggesting that this is indeed the causal mediator between anger and threat detection bias.
Can I ask you a question about that?
Sure.
Is it okay to ask questions?
Or do you want to wait till the end? Or?
It's about that study. So was there a reaction time difference in the study and the other ones?
There was not in those, no. We've since moved to a version of it where they respond not under time pressure, so where we add visual noise to the stimuli, and they have an open-ended response window. And there we do see some reaction time differences. But here they're responding within 750 milliseconds. And so although we didn't see response time differences, we have to think that that might be due to the truncated window. So there's a limited range of variability for that variable. Okay. So just to end this first portion of my talk, I just kind of want to conclude what we've shown as a whole in these studies. First, we demonstrated that anger produces a more liberal threat detection bias Our anger participants make more errors saying that neutral objects are guns than vice versa. Next, we demonstrate that anger seems to set the priors for what the mind expects to see. That is, our anger participants expect to encounter more threats, more guns in our task, and it's these biased expectancies, these biased base rate estimates, that drive anger's influence on bias, that produce the liberal response bias we see among angry participants. And I just want to take a moment, because I've been talking about bias, which has some negative connotations, and I've mostly focused on the types of errors anger increases. So I want to take a moment to say that these results are not inconsistent with the broader theoretical point with which I opened. This idea that emotions are functional. Anger is functional. Even though anger is producing a bias where people are making more false alarms, they're doing that so they can avoid ever missing a gun when it actually shows up. And so hopefully you can see why that would be adaptive in terms of survival. Like, anger is readying these people to cope with what's likely to come next given their emotional state. Okay, so hopefully I have convinced you. Experiencing a threat-relevant emotion like anger can impact people's threat detection bias, making them expect to encounter more threats, and thus to adopt a more liberal response bias. Do you have a question?
Yeah, I'll raise it very quick. So before we move into the, well, maybe you'll add to this at some point, but other threat-related emotions, do you examine those, like fear-related emotions?
That is a very good question. It's something I've wanted to do for a long time. The reason we chose anger as opposed to fear, for example, here, was that there was some trouble manipulating fear with the autobiographical recall task, or with any induction we could come up with that would allow us to compare it to other emotional states. And so we favored looking at anger because we wanted the ability to compare it to other emotions over fear. That said, what I think drives this effect is this conceptual overlap, this relevance, right? So anger could be elicited in situations involving aggression and violence, and so it's used as a source of information about guns. And so to the extent that fear is also elicited in situations involving violence and aggression, I think it would also produce this liberal bias here. That said, there's differences in terms of approach avoidance motivation between anger and fear. And so particularly if you used a shooting version of this task, you might see interesting differences between them. So if anyone has any ideas about how to induce fear,
I'm very good at inducing personal emotions.
we should definitely talk about it.
Experimentally.
Okay. Yeah.
I'm curious whether you find that C and D are correlated in your studies, and if so, what the correlation is?
In these studies, they are not. They haven't been correlated at all, at least not significantly. When we've moved to the noisy version of this task, where people can respond open-endedly, they do tend to be a little bit more correlated there, usually in the low to moderate range.
And how long does your entire task take from the end of the emotion induction? How long are they until your task is over?
Maybe 7 minutes total, 6 minutes. So they do practice trials before the emotion induction. So they learn the instructions and they get used to the controls, doing some practice trials. Then they do the emotion induction and move immediately into the task, which lasts about 5 to 7 minutes. Yeah?
Do the subjects know the number of trials, particularly in study 5? They know how many trials they'll see for the study?
I think we tell them, yes. We at least tell them how long it's going to take. So in study 5, actually, in particular, we doubled the task in length. And there, we didn't find any order effects. So they didn't do better on the first half than the second half. And we've looked at just the individual task, which is only 40 trials long. It's not super long. It's not enough for trials, really, to look at that in a kind of nuanced way. But, if you do first third, last third, we don't seem to see differences in sensitivity. Anything else before we move on? Great. So what I want to talk about now, what I want to do is provide some evidence that these same processes might be at play when we move from emotional experiences elicited in the lab to emotional experiences following a real-world instance of threat. And so I'll talk about a study where we look at changes in affect and threat detection over the first anniversary of the Boston Marathon bombing. And I just want to provide a little bit of background about the Boston Marathon bombings, although everyone in this audience is probably familiar. On April 15th, 2013, 2 bombs exploded near the finish line of the 117th annual Boston Marathon. They killed 3 people, injured more than 250 others. This happened less than a mile from our lab at Northeastern. The hunt for the suspects lasted another 4 days. It included 2 more instances of public bloodshed and a citywide lockdown in which businesses and schools were closed and residents were warned to stay in their home. So anecdotally, it was a very scary time to live or work in Boston. Everyone reported a lot of hypervigilance, a lot of jumpiness and unease. And of course, this was all amplified by just the immense amount of media coverage that particularly early on really sensationalized the devastation and the tragedy of this event. So given my research interests, I was very fortunate to receive some funding from the National Science Foundation. I've actually run several studies now looking at the impact of the bombings on Boston area residents in the last 1.5 years. I'm not going to talk about most of them, though I'm happy to chat with anyone who's interested. What I want to share today is the most recent of those studies. And so it's one that we just finished collecting data on less than a month ago. So you guys are really going to get like a first sneak peek at some forthcoming work that we're excited about. So this is a short-term longitudinal project, as I mentioned, looking at changes in affect and threat detection over the first anniversary of the bombings. So our participants came in 3 times, once several months before the anniversary, once in the weeks immediately leading up to the anniversary, and once a few months after the anniversary. And all of the participants completed the same experiment, and they all completed the same experiment all 3 times. We pulled our sample from the general public in Boston, and we tried to get about half people who lived or worked in Boston at the time of the bombings, and half people who are new to the area, so who did not live or work in Boston at the time of the bombings. And we called this our high and our low exposure groups, respectively. Also, because of some concerns about how people might respond to some of the experimental tasks, we also decided to screen for depression.